for charge tape. Just a quick introduction. The purpose of this lab was to observe the interactions between two strips of tape and determine how much excess charge was on one strip of those two. So our results from this experiment were that our observed model had 1.35 times 10 to the negative 8th coulombs of charge. Our computational model gave us 1.40 times 10 to the negative coulombs charge for one strip of tape. And then the number of electrons that we said were lost by the tape were 8.46 times 10 to the negative 10 coulombs. So just a couple fundamental physics principles that we're going over. The first being Newton's second law, F net equals ma. This is just saying that the acceleration of an object is directly proportional to the net force, which you can see right here. F equals ma, a being acceleration. And the second equation that we use is Coulomb's law, which is this equation right here. This equation is just saying that it's describing the magnitude of electric force between two objects, and for two different charges, then opposite charges, then that force is attractive. But with two like charges, that force is repulsive. So it can go either way. And just a breakdown of the variables, K is our coulombs, constant number right here. Q1 and Q2 are point charges, and R is the distance between those charges as well. So for our observed model, the length of the tape that we used was 0.2 meters, and from that we were able to calculate the mass of the tape in kilograms, that mass being 0.0002 kilograms, and our width was also 0.02 meters as well. And so we said that for our system was tape B, and the surroundings was tape A, and the rest of the environment in the lab. And as you can see in this diagram underneath the picture, we determined that based on a measuring stick that our distance between the two tapes as they repelled was 0.029 meters. And we have our calculations on this side right here. First, we calculated out the gravitational force on the tape, and we found that that was 0.00196 newtons. And because F net is 0, it means that the force of gravity and the force of the electrical force of B on A must be the same. And so we just plugged in the number that we got for gravity. We plugged that into our electric force, magnetic force equation for Coulomb's number right here. And from that, we solved for Q, and we got 1.35 times 10 to the negative 8th coulombs for our Q charge in our observed model. And then to see how many electrons that we lost, we just simply divided the charge of the tape by the charge of E, and that's equals the electrons lost. And from that, we got 8.46 times 10 to the negative 6 electrons lost in the process. In our computational model, as you can see right here, this is the setup. We have the two spheres, each representing a point charge for one of those strips of tape. And once we plugged in our equations and our values, um, GlowScript gave us a estimated charge of 1.40149 e to the negative 8th. And then here you see the amount of protons and electrons worth of charge, and they have to be even so that these two repel from each other, or else there would be some kind of attraction. So overall, these experiments were pretty similar. The observed calculated charge was 1.35 times 10 to the negative 8th coulombs. The computational calculated charge was 1.40 times 10 to the negative 9th coulombs. And some assumptions for the observed model was just that we assumed that the charge was evenly distributed on both pieces of tape. And for our computational model, we assumed negligible air resistance, and we used point charges to represent the tape as well instead of actual strips. And some potential sources of error was the tape grazing our hand and other surface during handling, which could neutralize the charge on that tape. The mass of the tape was calculated, not measured, so there is a little bit of room for error there. And the room humidity also possibly affected the charge because it was getting humid at that point in the day. So for discussion, if electrons had a positive charge and protons had a negative charge, the observations would not change. They would still interact the same, but instead we would be losing electrons in the interaction, and we'd be losing protons in the interaction instead of electrons. And it's important to come into as little contact as possible with the tape because otherwise that charge will redistribute in your hand or into other surfaces, and that would make the tape neutrally charged, which means that we would have to recharge it again before we could do the experiment. All right, thank you. Bye.